In the world of programming, what are data and data types? If you want to store any kind of data in your computer's memory, for example, if you want to save your own name in your computer's memory, you need to work with two main concepts. First, the data you want to store will be saved in a variable. For example, you create a variable called name and then store your own name in that variable. The second concept you need to be familiar with is the type of that variable. That means the variable you defined as name must have a specific type. When you want to store a name or a string or a text in a variable, the type of that variable is completely different from when you want to store a number in it. Let's take a look at them together. The first question that might come up for anyone new to the world of programming when encountering different data types is, why do we define different data types at all? Why don't we just use a single data type to store all our variables? That way, our job would be easier too. The answer can be summarized in a few parts. Imagine you want to store an article as a variable, and this article has 4,000 words and over, say, 20,000 characters. You definitely need to allocate some space in your computer's memory for this variable. On the other hand, you might also want to store a two-word phrase or even a single word on your computer. So the question that arises here is, if we were to assign a specific type of data, say, allocate 1 megabyte of memory to it, use this for all our variables, don't you think that would be a waste and misuse of memory? When you want to store a 4-letter or 4-character word alongside an article that's 4,000 words or 20,000 characters long. So what we've realized now is memory efficiency, that is, we need to define different data types based on our storage needs in our computer's memory, so that when we only need a very small amount of memory, we don't end up wasting a large amount of memory just to store that parameter. We should also keep in mind that the mathematical operators we want to use on our different data types can never be exactly the same. For example, suppose you have two text strings and you want to concatenate them, adding one to the end of the other. For instance, your first name and last name are stored in two different variables, and you want to combine these variables to create a new variable called full name. At this point, if you use the addition or plus operator, you expect that in the case of text strings, the second part, that is, your last name, will be appended to the end of your first name, creating a new variable. This new variable will be a text string containing your full name. But when you use mathematical parameters, for example, you want to add the number 4 to the number 8. Should a computer handle mathematical variables the same way it handles text strings? Certainly the answer is no. So, in order to know how each of the operators or mathematical operations we apply to our variables should work, we need to precisely define the type of each variable. Additionally, by strictly and accurately assigning appropriate data types, we can effectively prevent potential bugs and errors from occurring within our code. How so? Suppose we want to specify that only an integer can be accepted as input for a certain variable. Then, somewhere in your code, you assign a decimal number to it. The compiler will actively detect this in your code and give you a warning. It tells you that the number you defined was an integer and you are assigning a decimal number to it. So there is an error here, and it's better to go back and correct that mistake. Also, when using different types of variables, we can specify the level of precision for that variable as well. For example, you have a decimal variable in which you want to store 10 digits after the decimal point, or you have another variable where you want to store 50 digits after the decimal point. So, The level of precision for your variable is determined by the data type you assign and specify for that variable. With this brief introduction, let's go and review the different data types in the Mql5 language. But before we get into data types, let's introduce a good resource for learning the Mql5 language and getting all the tips and details about this language. If you open the Mql5 website, in the documentation section, you will have access to a completely solid and reliable source for all the functions, all the structures, and the details of this language. So if we want to review all the features that the Mql5 language has, we can use the documentation section to search for and select any function, data type, structure, or anything else we want, use it, and understand how that data type, function, or structure works. So our source for introducing and reviewing data types is the official Mql5 website and its documentation. To start, if I click on the language basics option and go to the data types section, here I can see the data types that are defined in this language. The first data type that we deal with in all programming languages and also in Mql5 is whole numbers or integers. 0, 1, 2, 3 up to positive infinity, -1, -2, -3 down to negative infinity. But as you can see in the left column, there are different types of these integers considered in Mql5. Char, uchar, short, ushort, int, uint long, and ulong. If you pay attention, the only difference between these various data types for integers is the amount of memory allocated to them and also the range of values we can assign to them. For example, in the char type, 1 byte of memory or 8 bits is allocated to it, and we can assign values from -128 to +127 to it. So if the number we want to assign to a variable is in the range of -128 to 127, we can use the char type. The next type is uchar, or unsigned char. This is used when the variable we want to assign a value to is only positive and does not consider negative values. We can use uchar in this case. As you can see, they have actually taken the -128 numbers out from here and added them to the end of these 127, which gives us a range from 0 to 255. Meanwhile, the memory size is still just 1 byte. But if we see that the variable we want to define requires a wider range, we can use short, which is 2 bytes. It covers a range from -32,768 to +32,767. Also, if we see that our variable will never take a negative value, we can use unsigned short, which, with the same 2 bytes of memory, will range from 0 up to 65,535. The next variable type is actually the integer type, which is 4 by testwise the size of unsigned shorthand, is used as the standard for signed types. After that, we also have long and unsigned long. But in this introductory course, there's no need for us to get too involved with these for now. Only if we know that our variable is extremely large, can we use unsigned, long, or long. Otherwise, we can always use the int type, and 4 bytes is reasonable for us. Also, if we go and check the integers on the Mql5 website itself, as you can see, if you click on any of them, for example, on int, you'll see that it shows 4 bytes of memory, or 32 bits, and the value starts from -2,147,483,648 up to a similar value on the positive side. And if you pay attention, the long type is 64 bits or 8 bytes, and you can assign it a much larger value. Just keep in mind, if you're sure that your variable will never take a negative number, you can simply use any of the types that start with the letter U, meaning unsigned, which gives you access to a much larger range of numbers. All right, let's go ahead and create an indicator together and define these data types on it to see how we can use them. In the folder that I've provided for this session, we click on it, then we click on the new option. Next, select data types and I type in int. I set it, I keep clicking next, and as you can see, a ready-made template for the indicator has been generated for us. Now, in order to define a variable, I won't go inside these functions. Instead, I'll do it in the global scope. In the global scope, I write int because I want to use an integer and I name it h, ending the statement with a semicolon. So, as you can see, the first word we use when defining a variable specifies the type, kind, or data type of that variable, which here is integer, meaning we've defined it as type int. The second part defines the name of the variable, and we'll discuss the rules for naming variables later. Finally, in C++ or Mql5, we must always end our statement with a semicolon. This semicolon tells our compiler, or actually our program, that I'm done with this line and it's reached its end. So now, if I compile this, as you can see, we don't have any errors. We only get that same no indicator plot defined for indicator error, which we're not dealing with for now. We'll get to that later. And as you can see, this data type has been defined as an integer and is usable. I can also define a short data type, which is much shorter, and I can name it whatever I want. In fact, if we look at it logically, since the value range of our short variable is from -128 to +127, it's better to define age as a short, and for example, we can define year as an int, and if we compile, we'll see that both of these variables still work correctly for us. The next data type we encounter is the logical or boolean data type. This type of data can only take two different states, true or false, 1 or 0, and it doesn't go beyond these two states. If we have variables that only have two states, we always use the logical or boolean variable for this purpose. To define this type of variable, we write bool at the beginning and give it a name. For example, is computer on? And we close our statement with a semicolon at the end. So take a look. Is computer on is a variable that is meant to show whether our computer is on or not. A computer only has two states. It can either be on or off. So for variables that only have two states, we use the boolean type. The next data type is literals or fixed values. We don't use this type of data to store any specific variable. Literals are actually a set of strings that are stored as Unicode and have various uses in the statements of this programming language. We will have these in all languages as well. For example, one of the literals we have is the backslash. For instance, if I open my editor and want to write a comment, say, I want to add some explanation about this variable and what it's used for, I can type two backslashes and then write, this variable is for storing age. Okay. Or for example, I can write, this variable is for storing name. The phrase that comes after the two backslashes is recognized as a comment, and these comments are never actually executed in the code itself. If I compile this, you can also see that its color has turned green. So this part is just for providing information. We can add comments in two ways. One is single line comments, which start with two backslashes. But if we want to write multi-line comments, meaning comments that span several lines, we start with a slash and an asterisk, and end with an asterisk and a slash. And here we say, this is a multi-line comment. And you can add as many comments here as you want. And even if you compile it, you won't have any problems. Our next data type is strings, which store text or character sequences. Usually when we want to store file paths, URLs, a specific message, a label for an indicator, or any other case where we need to save something as a text string, we use strings. To see an example of this, let's use the string keyword. And then how to name it. For example, I want to say username. We want to store the user's name. We set its type as string. The next type of data we deal with is decimal numbers or floating point numbers. These numbers are defined in two ways, and with two different variables in Mql5, float and double. The difference between them is the precision of the digits after the decimal point for each one. With float, we have about 7 digits of precision after the decimal point, and with double, we have 15 digits of precision after the decimal point. To read the documentation, it's enough to go into the data type section. From the floating point numbers, we select double. We see that double is 8 bytes with this minimum and maximum value it can take, and its type is double, while float is 4 bytes, which is half that amount. To define it, we just need to open our metadata and specify, for example, that our price should be defined as a double. We can also use float, though that's less common. For example, if we want to talk about candles, they were stored as floats. If we compile, we see that, again, there are no issues. Our next data type is color. Sometimes we need to use a specific color to display something on the chart, and we store that color in a variable called color, which takes up 4 bytes of memory. To test it out, let's define a color. For example, let's name it indicator color. And as you can see, this indicator color variable can store a color inside itself, and we can use it later. Let's compile it, no issues. The next variable we're going to introduce is the datetime variable. This type of variable is used for storing time and date. In programming, we have a concept called epoch time. Epoch time, or Unix epoch time, is a numeric value that shows the number of seconds that have passed since a specific reference point called the epoch. Our reference point for the epoch is the 1st of January 1970. From that date, any number of seconds that have passed can actually be represented as a datetime variable. In the Mql5 programming language, you can represent this number of seconds either with a long variable or with a datetime variable. But why do we use datetime? Because later on, when we want to assign values to each of these variables, by using the datetime variable, we can assign times with much greater readability. I'm going to define a variable called datetime. I'll name it current time, and later on, when we assign a value to this current time variable, you'll see why we don't use long or integer to assign values to variables that represent time. After we compile it, we'll see that we don't get any errors. Before we introduce more complex data types, let's take a look at how to assign values to variables. We start from the top and assign a value to the integer variable we created. I'll remove the comments so we can focus on it more easily. We want to assign a value to the integer variable. There are two ways we can assign values. The first way is like this. Right where we define the variable, we assign a value to it. For example, here I assigned the value 33 to the variable yay. How did this operation happen? By using the equals operator. Note that the right side of the equal sign is assigned to the left side. So the number 33 was assigned toin fact to the variable y. Of course, 33 isn't really correct. I can put 25 here instead. Well, for age, we can use 33. For variables that are boolean, we can use the expression true or the expression false. That is, we can use either the expression true or the expression false. Also, if we set it to 0, it is considered as false. And if we set it to 1, it is considered as true. For string variables, if we want to assign a value, it's enough to put the text string between two double quotes. For example, the username I want to set is my own first and last name, and as you can see, this name is placed between two double quotes. For double variables and assigning values, we can use decimal numbers. For example, we can say the price I have right now is this amount, and since we've used a decimal point and the type is double, we won't have any issues. Similarly, for float variables, we can also use decimal or fractional values, but when it comes to color and datetime, there are some differences. To assign a value to a color variable, we go back and refer to the Mql5 documentation. We open the color data type, and as you can see, there are different ways we can assign values to colors. The first method is the literal form, where you can set the RGB values red, green, and blue using this expression. Let me give you an example. For now, we'll name this variable color1. And I pasted exactly the same value here. CC is the color indicator inside two single quotes with 3 parameters. Basically, these are separated from each other. This is the first way you can assign a value to a color variable. The second method is when you want to use hexadecimals like this, which we won't go into much detail about. But if you want, you can look into it yourself. Again, it considers red, green, and blue, but it's no longer an integer. It's using hexadecimal. The third method, which is the default and actually used a lot in Mql5 itself. Colors that are predefined and have names, and basically you work with color names. The way to use them is that you say color, for example, color LR, with a lowercase c, and then you type the name of that color. For example, notice that if we write this Claire at the beginning, a list of colors that we can actually access will appear here, and we can choose from them. If you have a specific color in mind and want to have the exact colors, all you need to do is search for Mql5 HTML colors. It will list the web colors and these different colors here for you, and it also provides the name of each one, so you can use them here like this. And finally, the fourth way we can use our colors is when we use hexadecimal or integer codes, which have their own specific variables for coding, but we won't go into that much detail here. We will cover it in the advanced course. But to assign a value to the datetime variable, we again refer to the Mql5 website documentation and select the datetime type. And as you can see, you can observe various types of value assignments here. I will just copy one of them here as an example. And as you can see, it starts with the letter D. Between two single quotes, you specify the year, month, day, and at the end, the time is given as hour and minute. There are other formats as well, which include seconds, like this one. As you can see, there is also a reverse format where the year comes at the end. Only the hour is specified. Only the date is specified, and now you can also have just the hour alone. We won't go too deep into this topic. Just know that we can use the D expression and two single quotes to assign the value correctly. So pay attention why didn't we use long here? Because otherwise, we would have had to convert this value into seconds, get a number, and then put it here. But if we use the datetime variable, it will be much more readable for us here. So we've introduced the variables that consider the general data types for themselves. In the next session, we will cover advanced data types.